Alright, hi everybody, welcome to the ICT on the web where we teach or we try to teach courses online. So, what I suggest is this is for week 7. So, let's refer to iTalim and we start from there. And to this week, in week 7, we'll be discussing mostly about networking. So let's look at the slides and we'll see at week 7. We'll click on networking. What we'll be talking about is basically TCP IP networking, and we will cover just some of the practical issues, and we'll be doing some practical on Wednesday, but for Monday we'll just be covering slides. In general, we want to know what is TCP IP. Of course, if you want to know more about TCP IP, you should take some of our networking courses where we talk about how network TCP IP works and how it's being used in most routers like Cisco. However, in this course, we'll just be playing around with some of the TCP IP protocols, and later we'll see how it will work within the layers, addresses, and how it's being used for NAT, which is a network address translation. We'll also be covering about protocols, and this will be something like ARP or DHCP, right? And see how this is being used. Okay. Now, a TCP/IP is the most common networking protocol suite being used. It's the foundation of the internet. We've been using it for a long time now. But as for now, as for 2013, there's 2.8 billion online users, and 2016 is about 4 million, right? So the numbers are actually growing really fast. Now, networking applications typically use one or two transport protocol. We use either TCP, the transmission control protocol, or UDP, a user datagram protocol. Now, all traffic that carries TCP or UDP would be carried on the IP protocol, and it's the internet protocol, right? So that's why we call it TCP/IP. Now, IP itself is a packet oriented, and the routers don't really care what is in the packets or what came before it. So this is what makes it difficult. Now, in order to know about this, so we use some of this stuff like other protocols where TCP writes over IP, and this way it's connection oriented. It has two-way communication. It's reliable, and it provides in order transport of streams of bytes, right? So if we have a stream of bytes, we require TCP, right? So that it can be ordered in a certain way, and somehow we can distinguish packets which come first. Now, TCP also provides congestion control, right? So the congestion controls actually slows down when it slows down packet transfers when there is congestion, right? So, and when there's no transaction, which we can download or receive packets this way. So this actually makes the whole system faster with the when it tries to figure out what resources are available. Now, TCP also provides flow control, and this is important because we don't want to overwhelm any client, right? Or any receiver receiving the packets will not be overwhelmed with the number of TCP packets that's arriving. So by doing this, by having a flow control, is to make sure that this doesn't really occur. Now, besides TCP, we also have UDP. Now, UDP is unreliable, but it's quick and easy to transport of all the individual packets, right? Now, it is a bit different from TCP, particularly sessionless, but it's usually used when we want to transmit packets faster. Now, if you look at the TCP/IP networking stacks, and some of you guys are already familiar with this, right over the top we have the application layer. On the application layer is where users initiate a data transfer, and this layer passes a request to the transport layer, which is right here, and this is usually where your application is. When you write an application and you create a network application, it will open up a socket and try to put packets in on the application layer, right? So this is not like, for example, HTTP protocol. Whenever we write a browser application, for example, that browser will open a TCP/IP protocol, which will send HTTP packets. Now, over in the transport layer, it will attach a header and passes the data to the network layer. At the network layer, source and the destination IP addresses are added for routing purposes. So this is so whenever a machine tries to connect to another machine, it will try to put the source and destination IP addresses so that it knows how to be transferred. Now, on the data link layer, it will do some error checking flow over the flow of data with the protocols as above, and send it to the physical layer, and the physical layer move the data out and in along the transport medium. This medium might be an Ethernet, could be your modem via PPP, this is or something like Streamix, over optical cable, over Wi-Fi cable, Wi-Fi network. So this could be various 3G network, various kind of physical network that's available. So you can see this is a lot of layers that goes through, and we can pretty much do some sort of filtering in any part of this layer. Now, each layer has encapsulates some kind of data, and for example here, if you look at this picture, when we send data from a source to a destination over here, the application itself would just put the message encapsulate the message in the overall TCP/IP stack or overall packet, right? So when we put first, the application will put the message, and the transport layer will put header information, and this header information could be IP addresses of the source and the destination, and the network layer will put extra information. For example, network layer here, right? I'm sorry. So the transport layer attach a header and passes the data to the network layer. This header information tells you what the application is and other stuff. The network layer puts some IP addresses, and down at the link layer, with the data link layer, we put an extra header over the information about the protocol itself, and we'll send it over the physical layer, and when it reaches the destination, it will open up these messages and figure out where the message, how this encapsulation will get back to the messages that was intended to be sent, right? So this is basically how it is. Now, UDP actually has a smaller header size compared to TCP, and the Ethernet frame adds extra 18 bytes to the overall messages. So now we'll get into how the addresses works, and before we continue, I'm gonna, before we continue, I'm gonna end this video series for part one, and we'll continue later on part two.